Hello friends, welcome to my channel. Let's start the topic. At one point in history, we thought that sand is the smallest particle in the world. Then mankind discovered atom. If you were to take an apple and cut it into half, then in half again, and so on, where would you end up? Could you keep on going forever? Or would you find fundamental indivisible particle out of which everything is made? Before 19th century, atoms were considered as the fundamental particles, but later it was found that the atoms consist of electrons, protons and neutrons. Discoveries in 19th century have changed the way we understand the world. Understanding of the atomic structure and finding fundamental particle has been a huge focus of scientific community. The term fundamental means that the particle does not have a substructure. That is, it cannot be split. In 1964, Murray Gell-Mann took a huge step forward and suggested ever smallest particles predicted by humans having the size of 10 raised to power minus 19 meter. Yes guys, quarks are the smallest particles ever discovered. From the stars overhead to the atoms in our DNA, all matter is composed of fundamental particles. Particles that cannot be divided into smaller parts. Quarks are fundamental particles. They don't have specific shape, but they do have some properties which we'll discuss in this video. In 1950, the list of known particles including pions, kaons and sigma particle, with new particles being discovered all the time. Soon there were dozens of types of particles all following different rules. Later prediction of quark gave simple explanation of complex mysteries. Quarks are bound to each other by strong force which bind them so tightly that one quark cannot exist by itself. Quarks could only be found on a group of two or more. As I already told you guys that quark is a fundamental particle of matter. The universe doesn't seem to make any sense without quarks. Quarks combine to form composite particles called hadrons, the most stable of which are protons and neutrons. Over the last few decades, physicists realized that you could never see an isolated quark on its own. They can only be found within hadrons. Gell-Mann received Nobel Prize in 1969 for his work in classifying elementary particles. The name of quarks are quite weird. Their names are up, down, strange, charm, top and bottom. Up and down quarks are named based on the components of their spin. Strange quark got its name because they were observed in particle decays that have slightly longer lifetimes than they should have done. Charm quarks were given the name because scientists were fascinated by the symmetry it brought to the subnuclear world. Top and bottom quarks were chosen because they were the logical counterparts of up and down quarks. They are in order from highest to heaviest in weight. All quarks also have antiquarks. Let's move on to the properties of quarks. Two important properties are electric charge and spin. Quarks have fractional electric charges. This was the new concept as the fraction of charges have never been seen before. They have either plus 2/3 or negative 1/3 times the charge of elementary particle. For example, up quark have the charge of plus 2/3 of the charge of the electron and down quark with the charge of minus 1/3. They all have different masses. Up and down quarks are most common and least massive. Bottom is the most massive quark. They have another property called spin. They obey Pauli exclusion principle with the spin half. Quarks possess the property called color charge. There are three types of color charges, that is blue, red and green. Every quark is complemented by an anti-color, anti-blue, anti-green and anti-red. Every quark carries a color while every anti-quark carries an anti-color. Now yes, I am going to show you an interesting slide. There are 6 flavors of quarks and these 6 flavors successfully account for all the known mesons and baryons. The most common baryons are protons and neutrons. Each of them is made up of up and down quarks. Mesons are formed by the combination of 2 quarks while baryons are formed by the combination of 3 quarks. Here in this slide we can see that protons have a charge of positive 1 and neutrons have no charge. On the left bottom corner you can find charges of all the 6 quarks. The proton was found to be made up of 2 up quarks and 1 down quark. If we look on total charge of the proton, that is plus 1, and fraction of charges given on quark, 2 up quarks will have charges of plus 4/3. Adding it to the down quark reduces the charge to 3/3, which is equivalent to 1. While neutron consists of 2 down quarks and 1 up quark, which makes total charge of 0. Now scientists are searching for Higgs bosons. They are also called God's particle because physicists believe that it will be the smallest fundamental block of everything. By understanding Higgs bosons, we will finally understand how universe was created. Guys, this was all for Quarks. Hope you like this video. If you like this video, give your feedback and subscribe my channel. Give thumbs up and see you soon with a new video.